Hello class, we're about to start section 8.1 Finding Roots. What is the square root of a number? The reverse operation of squaring a number. The positive or principal square root of a number is written with the symbol. This is the square root symbol. The symbol negative square root is used for a negative square root of a number. The simple square root is called a radical sign. Always represent the positive square root, except that the square root of 0 is 0. The number inside the radical sign is called the radicand, and the entire expression is called a radical. Now, the square roots of 25 are 5 and negative 5 because 5 to the second power is 25 and negative 5 to the second power is 25. A perfect square is a number whose principal square root is non-negative. Well, remember what was stated up here. For the time being, we're going to use the positive square root. Even though this has two answers of 5 and negative 5, we're just going to use the positive 5 for right now. Okay, now it says find square roots. List all of the integer perfect squares from 0 to 225. So what we would do is this here. We would take 0, which we know 0 squared is just 0, and the square root of 0 is 0. 1 squared we know is 1. And 2 squared we know is 4, but the square root of 4 is 2. And so on. We go all the way down a list here. Because we know 9, the square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, and so on. Now, it says find the square root. We want to know the square root of 10,000. The square root of 10,000 is 100, because 100 times 100 is 10,000. Now we look here. We have a negative sign on the outside of the radical. So we would just carry this negative sign over. The square root of 49 is 7. So our final answer here would be negative 7. Remember, under this radical here, our answer was positive. But because it was a negative on the outside, it became negative 7. Now it says here, example 2, find all square roots of 289. So they're asking us for the square root of 289. And remember, we're just dealing with the positive square root of 289, which will give us 17. Now it says here, example 3, evaluate. We had a square root of 36, which is 6. That's correct. Now with B, we had a square root of a fraction. This is what you should do with a fraction. Take the square root of the numerator, square root of the denominator. This means the same thing. Whenever a whole fraction is under a square root, you could take the square root of each individual term here. Square root of 1 is 1. Square root of 9 is 3. So the square root of 1/9 is 1/3. Now we go here to C. The square root of 33 minus 8. Now, whenever you have terms with an operation separating them, like you had 33 minus 8 here, under the radical, you perform this operation first, then you do the radical. So it'll be the square root of 33 minus 8 is 25, and the square root of 25 is 5. Now we come here to D. Now if you notice, the operation is not under the radical. So we do the radicals first, or square roots first, and then add them together. So the square root of 144 is 12. And the square root of 25 is 5. 12 plus 5 is 17. Now we go to objective 2. It says evaluate models containing square roots. It says racing cyclists use the formula V equals 4 times the square root of R. So let me just write that here. V is equal to 4 times the square root of R to determine a maximum velocity V in miles per hour to turn a corner with radius r in feet without tipping over. What is the maximum velocity that a cyclist should travel around a corner of radius 9 feet without tipping over? So we know radius is our r. So we'll substitute in 9 feet for r. So we have v is equal to 4 times the square root of 9. Now we don't have to write feet, but we can. Okay, so the square root of 9 will give us 3. So we have 4 times 3 feet. 4 times 3 will give us 12. Now, since we're dealing with velocity, this is in miles per hour. So this is 12 feet. So our velocity is 12 miles per hour. Because remember, velocity is measured in miles per hour. Okay, now we scroll down here. It says use a calculator to find decimal approximations for irrational square roots. If a is a positive real number that is not a perfect square, then square root of a is irrational. If a is a negative real number, then the square root of a is not a real number. Complete the following table. The square root of 100 is, that's a perfect square, so it's rational. Now you see how the letters are jumping, so what I'm going to do is, for rational from now on, I'm just going to write R. For irrational, I'll write I. And for not real, I'll write NR. Okay, the square root of 100 is 10. Okay, now we have the negative square root of 49 over 81. Now remember, this negative is on the outside. The square root of 49 we know is 7, and the square root of 81 is 9. So this is a perfect square, so it's rational. Well, you know what? I'm going to write the R on the outside because for some reason inside this box it jumps. So this R will represent rational. And then over here, like we said, this would be negative. And then the square root of 49 is 7. And that's all over 9. Because the square root of 81 is 9. Now we go here to the square root of 30. Now the square root of 30, we would do it like this here. This is not a perfect square. So, and this isn't negative. Class, because everything kept jumping, I took the liberty of filling this out so we could go through this. Okay, again, we had the square root of 100, which was rational, and we know the square root of 100 is 10. The negative square root of 49 over 81, that was also rational. But we know the square root of 49 and the square root of 81 will give us negative 7 over 9. Square root of 30, that's irrational because it's not a perfect square. And when you put in your calculator, round to 2 decimal places, and that will give you 5.48. Now, we have another negative sign on the outside of the square root. So it's irrational because this isn't a perfect square. We carry over our negative, and then the square root of 72, we will round it to 2 decimal places. It'll give us a negative 8.49. Now we come here to the square root of negative 16. Because the negative is under the square root, it's not real, and then there's no real solution is its answer. Now, I'm going to streamline these last 3 answers. All 3 of these are irrational. None of these are perfect squares, and also none of them are negative under the radical. So these are all irrational. When you put them in a calculator round into 2 decimal places, you would get 2.85, negative 11.45, because you had to carry this negative sign over, and also 3.61. Now, we scroll to the next page. It says use a calculator to approximate the expression, round to 3 decimal places. So when we put this in our calculator, it will give us the approximation of 2.153. Now remember, the squiggly equal sign means that this is an approximation because this is not an exact answer. Now we go to objective 4, find higher roots. Before we can think about higher roots, we should familiarize ourselves with the first few perfect cubes, fourths, and fifths. Okay, here we got 2 to the second power, which is 4, 2 to the third is 8, 2 to the fourth is 16. Now our next step would be 2 to the fifth power. Now this jumps a little bit. So 2 to the fifth power, that's 2 multiplied by itself 5 times. And that would be 2 times 2 times 2 times 2 times 2, which would give us 32. Now I'm going to write 32 on the outside here. And that's what 2 to the fifth power is. Okay, now, okay, class, because the numbers were jumping, I just took the liberty of filling it in. So we had 2 to the fourth is 16, 2 to the fifth is 32, and then also all of the rest here. And we know that the exponent means that this number is multiplied by itself that many times. So like here, 5 to the fourth power, it's the same thing as saying 5 times 5 times 5 times 5. And that would give us 625, and so on. Now it says definition of the principal nth root of a real number. Now, inside of your radical here, this is considered to be your nth root. Now, when we do a square root, you notice that there is no n on the inside of it. I'm going to put a 9 here. We know the square root of 9 is 3. But the n here is 2. Even though it's not shown in a typical square root, the n is not shown. But when it's not shown inside here, it's assumed to be 2. That's why it's called a square root. Now, it says here the cube root is 64. We need to find 3 numbers multiplied together that will give you 64. And that number is 4. Now we have B, the negative cube root of 1/8. So it'll be a negative, it'll be the cube root of 1 all over the cube root of 8. So it'll be negative, the cube root of 1 is 1, the cube root of 8 is 2. So it'll be a negative 1/2. Now it says find the indicated root. The cube root of negative 1000 will be a negative 10, because negative 10 times negative 10 times negative 10 is a negative 1000. The fourth root of a negative 16 is not a real number. Because remember, if our index is an even number, we cannot have a negative number under the radical. The fourth root of 16 is 2. And the square root of 16, we know, is 4. We scroll down here to E and F. The negative fourth root of 256, it'll be negative. And then our final answer here would be 4. So it'll be a negative 4. Now we have the fifth root of a negative 1. So this will end up being negative 1. Now if you notice, when your index is odd, you can have a negative number under the radical and it will give you a real number answer. But if your index is even, like we showed up here, when your index is even and the number under the radical is negative, then it'll be not a real number. Now, this is actually it for this lesson. So we'll start section 8.2 in the next video.